In this video, we will simplify radicals. So first of all, let's talk about the definition. N root of x to the n. So when we have the index of the radical, which is this number, the same with the power of the whatever expression you have under the radical, like x to the n or 7x plus 5, everything to the n, for example. So if the index is the same with the exponent, then we have two situations. If n it's even, so if the index of the radical is 2, 4, 6, and so on, the answer is absolute value of x. So basically, I want you to think of changing from radical expression to rational expression. So it would be x to n over n, which would make it x to the first, or x. But because square root has to be square root of a positive number, so under the radical we have to have a positive number, and is going to produce a positive number, then to make sure that we get this x, it's positive, then we put absolute value of x. And we have another situation if n it's odd. So if, for example, you have third root of x to the third, then is just x. So if you have cube root of x to the third, like we have in this example here, then it's going to be x to 3 over 3, which is just x to the first, or x. So we are not worried about putting absolute value in our answer. So it doesn't have to produce a positive number, because I want you to think of this example, cube root of negative 27, that is negative 3, because negative 3 to the third is negative 27. While if we talk about square root, for example, of negative 2 to the second, well, we cannot just cancel the indices, this one and the exponent, and say negative 2, because we know that square root of a positive number is going to be a positive number. So that's why we are going to put absolute value of negative 2 to make sure we get a positive answer. And if you look at it in a different way, like square root of negative 2 to the second, well, we can do the computation. Negative 2 to the second, it's actually 4. Square root of 4, it's 2. So we do get that. So that's why here, square root of x squared, we're just going to say absolute value of x. Fourth root of x to the fourth, so I am here. Fourth root of x to the fourth is going to be absolute value of x, because the indices cancel, right? But we want to make sure we produce a positive value outside the radical. Cube root of negative 12 to the third, the indices and the exponent cancel, so we get negative 12. Because it's an odd index, we have no problem getting a negative number. Here, when we have fourth root of negative 3 to the 4, we are going to get absolute value of negative 3, which is 3. So just a quick summary. If we have even root of a positive number, we will always produce a positive number. If we have odd root of a positive number, we are going to get a positive number. If we have odd root of negative number, we are going to get a negative number. And if we have an even root of a negative number, like for example, fourth root or square root, let's say, of negative 81, well, does not exist in real number set. And we are going to talk about complex numbers, but not in this lesson. So two properties that are important when we discuss radicals are n root of a times n root of b. It's n root, a longer root of a times b, and n root of a over n root of b, it's a deeper n root of a over b. So let's do a couple of problems. And let's look at these 1 through 8 problems, but I'm going to start with one that actually has numbers, and then I'm going to do the letters one. So I'm going to do example 7. So we have 6 times square root of 56. So it's square root, if I don't see any index there, then it's 2. So the plan is, if I actually had perfect square, I could calculate the square root, right? So the idea is to try and write 56 as a perfect square times whatever factor we get. So 56 is 2 times 28, or 2 times 2 times 14. So 14 is not a perfect square, is 2 times 7. So how about we write 56 as 4 times 14? So now, based on the property that I said before, I can separate it in square root of 4 times square root of 14. So it's 6 times square root of 4, it's 2, and then square root of 14 stays inside. So we get 12 square root of 14, final answer. So 56 could be written 2 times 28, but that doesn't help for our problem. We want to write the numbers under the root using a perfect square, factors, and in those factors we should have perfect squares. So let me try another one, this example 8 from here. So 5 times 24, I'm going to write it 4 times 6. So again, I can say 5 times square root of 4, it's 2, and square root of 6 cannot be simplified, so we end up with 10 square root of 6. So now how do we deal with letters? Let's take a look at example 1. Well, the index here, it's 2, right? So we have square root of, and I'm going to write x to the 9 as x to the 8 times x to the first. So by doing that, I'm not changing the problem, right? I have 8 plus 1, like properties of exponents is 9. But the reason why I chose 8, it's because having index 2, I can separate it into square root of x to the 8 times square root of x. Now, square root of x to the 8, it's x to the 4th, or based on what we talked before, I could put absolute value of x to the 4th to make sure it's going to be a positive value, but I'm not going to do that because x to the 4th, it's obviously always positive. And another reason why I'm not worried about absolute value is because they said assume all variables represent positive real numbers. So this quantity, no matter what exponent would have had, it's going to be positive. And then square root of x, because this quantity, I didn't simplify it. So the final answer is x to the 4th square root of x. So be very careful how you write your exponents. It's x to the 4th, and this is square root of x, so that you don't confuse the index with the power. Let's take a look at example 3. So example 3 has 4th root of x to the b to the 7. So I'm going to write 4th root, and b to the 7, I'm going to write it b to the 4th times b to the 3rd, because 4 plus 3 is the 7 that we had here. And I am trying to use multiples of this 4. So multiples of 4 would be 4, 8, 12, 16, and so on. So out of all these numbers, the number that it's a multiple of 4 and it's included in the 7, or it's less than 7, is going to be 4. So I'm going to separate now into 4th root of b to the 4 times 4th root of b to the 3rd. Now, 4th root of b to the 4 is just b, or I could put absolute value of b, but I'm not worried about that because it says represent positive real numbers. And this term here, 4th root of b to the 3rd, cannot be simplified further because the index of the radical is higher than the exponent. Now, we can do example 5 mentally, right? It's v to 24 divided by 4, so that's v to the 6, and no absolute value because v represents a positive number. But looking at 6, it's 4th root of v to 25. So now 25 divided by 4 doesn't divide evenly, but based on the example 5, I can say v to 25 is v to 24 times v to the first, right? And if we separate into 4th root of v to 24 times 4th root of v. Now, 4th root of v to 24, it's v, and then we keep 4th root of v to 4th root of v would be the final answer. V to the 6 fourth root of v. Okay, and let's take a look at one more. Let's look at this one. Simplify example 9. Assume all variables represent positive numbers, so we don't worry about absolute value. Now, it's cube root, so I'm going to separate this cube root into more radicals. So cube root of 250 times cube root of x to the third times cube root of y to the fifth. But y to the fifth, because I have cube root, I'm going to write y to the fifth as y to the third times y to the second. Because 3 plus 2 is 5, and I need the 3 so that the index with the exponent are the same, or multiple. The exponent, it's a multiple of the index, times cube root of z to the 6 times z to the first, right? Because 6, it's a multiple of 3. 7 was not a multiple of 3. But I could write 7 as a multiple of 3 by 6 plus 1. Now, cube root of 250. 250 can be written 125 times 2. Then, cube root of x to the third is just x, right? 3 over 3, x. Cube root of y to the third is just y. Cube root of y to the second is going to stay the same. So this term with the radical stays the same because I cannot simplify them. The index and the exponent, the index is larger than the exponent. Then cube root of z to the 6 is z to 6 over 3, which is z to the second. And then cube root of z to the first, this term. So now, cube root of 125, well, 5 times 5 times 5, it's 125. So that means 5 to the third, it's 125. So cube root of 125, it's just 5. So I'm going to write 5, and then x and y and z squared, I'm going to put them together. So x, y, z squared. And then I'm going to put a cube root, a longer cube root, and I'm going to put the terms that stay inside the cube root. And that would be 2y to the second z. So this would be the final answer of this. Okay, and I'm going to do 10. Let's do 10 so that we review the other property. So when we look at square root, right, deep square root of a to the 9 over a to the fifth, I can actually say square root of a to the 9 over a to the fifth, it's a to 9 minus 5, properties of exponents, that's a to the fourth, right? And that's equal to a to 4 over 2, which makes it a squared. And again, I'm not worried about absolute values, because this index being an even number, we should, because they said assume all variables represent positive numbers. I hope this helps. Actually, I want to do one more. So this example 13 has cube root of 4x times cube root of 2x times cube root of 8x. So individually, I cannot do much about them, but if I write a longer cube root and I put them together, I get 4x times 2x times 8x. And then if we multiply them, we get 4 times 2 times 8, that's 64. And then x times x times x, that's x cubed. So if I separate this into two radicals, cube root of 64 times cube root of x to the third, we actually get cube root of 64, it's 4, because 4 times 4 times 4, it's 64. And cube root of x to the third is just x, because when the index and the exponent are the same, we get x to the first.